Alright, welcome back again. This is electron configuration. We did this in class the other day, but this is the video in case you want to look at it for testing purposes. So let's go ahead and get started into this. Okay. So we have sublevels, or 4 blocks, S, P, D, and F. The different sections of the periodic table are very important to understanding electron configuration. Know your SPDF. Some people do fart. I would write that down if you don't have it in your journal already. It is some people do fart, or some people don't fart. There are 4 blocks in the periodic table, and we have the S block, the P block, and the F block. Whoa, back it up. Okay. Remember these special rules? In the D block, you have D minus 1 and F minus 2. Take that N out of there. I forgot to do that. Don't have those in there. Let me make sure my pen is working. Pointer, options, pen. Okay. Make sure it's just, why is this thing not working again? Alright, got it working. So it's D minus 1 and F. F minus 1. I mean minus 2, sorry. Minus 2, minus 2, minus 2. Okay? Alright. So what does SPDF mean? They refer to the sublevels within the principal quantum level or main energy level. So what I need you to write down is SPDF. Make sure you have the rule, the D and F rule, that some people do or don't fart. And then here we have, start right here where it says so for the main energy level number 1. This will help you if you get to use your notes in class. Okay, so if you're in energy level 1, there's only one sublevel. That's the S. Okay, if you're in energy level 2, there are 2 sublevels, S and P. But when we get to level 3, there are 3 sublevels, S, P, and D. And I'll show you those on a periodic table in just a minute. So we have 3 energy levels. Then, if you need to stop the video, stop it here, copy down what I underline, like that section right there. And also this one here. If you're in main energy level 4 and 5, you have all 4 of your sublevels, S, P, D, and F. When you get into level 6 and 7, there are only 3 sublevels, S, P, and D. You'll see here in just a minute. So let's go to our periodic table. This is what I mean. If you look right here, this is level 1. You see an S here and an S here. Then you go to level 2. You see the S orbital sublevel and the P sublevel. You go to 3. There's a 3 sublevel. Here's a D3, P3. Okay, 4. 4S, 4F, 4D, and 4P. Then you see it's 5. 5S, 5F, 5D, 5P. Then you go back to 6. 6S, 6D, 6P, and then 7S. Now the S orbital, you don't see a P over here, but there is some more elements over here. We don't use those very often, if at all. In this class, we will not use them at all, so don't stress on that one, okay? But just know they are there, okay? And I want you to copy down this statement right here, because this is how the order goes for writing electron configurations. 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. You'll see in a minute in the next slide, one of the next slides, that I have some examples of this. Okay, so an example, we have arsenic. Get all this up here. Okay, the first number is which row it's in. Remember we pointed to it on the periodic table with our finger, and we found that it would be in the 4th level, and that it's in the P block, and it's 3 blocks over, so 3 electrons over. But in order to write the whole address per se, the quote-unquote address, which is the electron configuration, Remember I said you have to always start every address with 1s2. Then you touch every single element after that. So you'd hit hydrogen, helium, lithium, beryllium, and so on. So then you're in the 2 level. You have the S or sublevel and 2 blocks. 2p6, 3s2, 3p6, 4s2, 3d10. Because we're just reading it like a book, and you'll see. Let me back it up. Oops. Where arsenic would be right here. This is where arsenic would be. So when you look at it, you're going to hit 1s2, 2s2, 2 spots, 2p6, 3s2, 3p6, 4s2, and then now you're in the D block, 3d10, then you go back into the P, but it's the 4p, 4p3, and that's arsenic right there. That's where arsenic would lie. Okay, so the character is the block it's in, which refers to the sublevel. And the superscript, which it is a superscript, is the total number of electrons in the sublevel or the orbitals. Okay, so here's a shortcut, kind of a diagonal if you want to copy this down. And I'm going to go ahead and put everything here so it covers this up. Okay, so we always start in the 1s level. Then we go to the 2s level. Then we go down, then we go back up here. So here's how this works. Start here, then you go here, oops, here, here, and so on. All the way down. So it goes 1s, 2s, 2p, 3s, 3p, 3d. 3p, 4s, 3d. So you kind of keep going back. This I find might be a little confusing, but some of you guys might enjoy looking at it or actually figure it out from here. I enjoy looking. I like the way I do it with the periodic table. I find it easier. This is easy for some people. Okay, so we have the 4D and D4 and the D9 rules. This is not going to be. We're not going to do this too much, but I will give it to you. Sometimes an electron configuration will end with a 4 or a 9 electrons in the D sublevel, and these are unstable. What will happen is that they will steal an electron from the S sublevel to stabilize it. So if you notice right here, this ends in a 4, but what happens is we steal it and it becomes 1 and 5. The one thing I want you to know here is we will never give you this one and on a test. So chromium will never give to you. Silver will never give to you, but here's a 9. This is how it should be written. This is what actually happens in an electron. Okay, I'm going to come back in the next video and do noble gas configurations.